today we look at the fourth and final conic section. It's called a hyperbola. It is created similar to how the ellipse was. It says the definition of a hyperbola, the set of points whose difference between 2 points is constant. On the ellipse, the sum to those points was always the same. And so if you have a point on this hyperbola, the difference of this distance and this distance should always be consistent. So for instance, if this is 25 and this is 5, the difference of those two is 20. And so that should stay consistent no matter what point you're at on the hyperbola. So that distance right there and that distance right there, maybe this is 3, that ends up being 23. So the difference of those two is still 20. All right, so every point on the hyperbola would do that. And then you could come over here to this side and it would do the same thing. It's just that this would be your short distance, this would be your longer distance. All right, so that's how the hyperbola is created. Let's look at some of the key parts of the hyperbola. When you're looking at the equation, it is super similar to the ellipse. The only difference is this right here. On a hyperbola, we're going to be subtracting those two fractions. But this still stays the center. This still tells you how much you're going to go left and right. This tells you how much you're going to go up and down. You're going to still get those same 4 points. However, you build this differently. Okay, so the one thing we need to talk about before we try it is that you have 2 axes. And so let's just kind of sketch this real quick. Here's what's going to happen. Here's your axes. And so just to keep life simple, let's center this at the origin. So let's say it was centered at the origin, and let's say that you were supposed to go left and right 3, and then you went up and down 5, we'll say. And what you do with those 4 points, instead of creating an ellipse with those, what you do is you create a box. That determines how big that box is. And then what you'll do is you'll draw in the diagonals of that box. Those diagonals are actually asymptotes that your hyperbola will actually approach. So it says here, the transverse axis is always the positive term. So when you look at this, this is the positive term, and because of the minus sign, this is the negative term. Now, that actually won't always be the case. Sometimes you'll have your y value on the first fraction and your x value will be the second fraction. If that's the case, then the y would be the positive term. All right, so the transverse axis is always the positive term. In this particular example, if I'm just basing it off this equation, I would say the x is the positive term. And so this is my transverse axis. Now notice it's not the longest one necessarily. Could be, doesn't have to be. It's just the one that comes from the positive term. So this is my transverse axis. This is what we call the conjugate axis. And whichever one is the transverse, whichever one is the positive term, tells you how to open the hyperbola up. In other words, in this example, since the x is positive, then these are going to be vertices. And the hyperbola comes along and approaches that asymptote. It touches right there at the edge of the box, and then it comes and approaches this asymptote. And then you do the same thing on the left side. Approach that asymptote, come touch the box, and then go approach the asymptote again. Now, if the y happened to be the positive term, then instead of the branches of the hyperbola opening right and left, we would have drawn them up here, and they would have been up and downward. So be looking for that sometimes. All right, so let's just graph a couple. All right, so starting off, again, we start off simple with nothing happening in the numerator, so the center of this hyperbola is going to stay at the origin. And then I have a 9 underneath the x, so that tells me to go left and right 3. And I have a 16 on the y, so that's going to be up and down 4. And with those 4 points, I'm going to create a box. And then I'll use preferably a straight edge of some sort. I'm just going to freehand it, but you really want this to be an accurate diagonal that goes corner to corner. And same thing over here. All right, and then we're going to draw the hyperbola in there, which is the official graph. Now, when I look at this, I can see that the x term is first. It's the positive term. So that means I'm going to be open along the x-axis. I'm going to open to the right and to the left. And so it's going to look like that last example. It comes in, just touches the box right there at the vertex, then goes on. Same thing here. All right, the one other thing I want you to put in there are the foci. The foci, just like in the parabola, are always in the cup of it. Same thing with the hyperbola. You have 2 foci. You're going to have one right here and one over here. Just like in the ellipse video, we're going kind of, this is the light version, meaning I'm not going to get real in depth on where those foci are or what those actual ordered pairs are. Just know that the farther they get away from the vertex, the more this opens up. And the closer they are, the skinnier it is. We just kind of put them out there in the cup of the hyperbola somewhere. All right, let's try one more of these. On this one, the center is going to be -3, -5. I'm going to go left and right 5, up and down 3, draw the box, put in the diagonals, and then look and see which term is first. Okay, so once again, the x is the positive term, so that means I'm going to be opening this thing on the sides. Touch the box, go approach. Come over here, touch the box, go approach. All right, always put the foci in the cup of the hyperbola. Okay, how about if you try one? This one's all yours. Now, I'll give you a hint before you get started. Notice that on this one, the y comes first. So be careful because this is all of your y stuff. When you're doing your center, this is your y value. This number here tells you how much to go up and down because it's underneath the y. So give this one a shot. I'll wait for you. All right, this is what you should have had. The center actually ends up being at -3, 1, because the x and y are swapped here. And then make sure that you went left and right 4 and up and down 7. Okay, I totally didn't do that one right. I don't know why. I only went up and down 5. Okay, so sorry. I should have actually gone up and down 7, so that should be taller than what it is. I can't erase very good, so I'm just going to call it good. The y's or tell you it comes first, so that tells you that it should be opening up and down. Make sure that you put the foci in the cup of your hyperbola. So it should look similar to this, only a little bit taller. All right, let's try one more where we're going the other direction. What if I just give you all the information? Could you come up with the equation? All right, so just like with the ellipse and the parabola, I like to sketch out what I'm looking at here. So let's see what they've got for me. The vertices are at 1, 4, okay, so somewhere like right there, and then at 1, -2, so somewhere like that. Those are the vertices, so the box is going to do something like, actually let me undo that. Oh, that's not going to erase very nice, but this is going to be, since those are the vertices, that's going to be my transverse axis. So I know that this hyperbola is going to open up and it's going to open down because those are the vertices. So that tells me since it opens up and down, I should have my y's come first and have them be the positive one. All right, the next thing I need to know is what the center point is. So if you think about, this one was up 4, and this one was -2, so that's a total distance of 6. So that would be 3 and 3. All right, so if this was up 4 and then I went down 3, so that's at a 1. So that ordered pair for the center should be, well, I'm still over 1 because both of these were 1s, still over 1. And then it happens to also be up 1. All right, and now I also happen to know what to put in for my denominator because I know how big this was. I went up and down 3, so that's going to help me with my denominators. And then the other piece of information is that the conjugate axis is 14 units. Okay, that's pretty long. This one was only 6, so 14 units long is much longer here. And so the box is going to look something like this. And since it's 14 units long, that means I'm going left and right 7. Okay, that should be enough to write our equation. Let's get started. So since it goes up and down first, or the graph goes up and down, I know the y goes first. So y minus 1, I get that from my center, squared. Over that, a hyperbola is always a minus sign. And then you got your x, it's also a -1. That's your center. It's going to be a fraction, always equals 1. Okay, so as far as looking at my picture, I went up and down 3, so that's going to put a 9 here for me. Went left and right 7, so that's a 49 there. And there's my equation. All right, that's all I've got for you. Good luck.